This is a follow-up to my video about the Kershaw speed bump, mainly about the G10 Speedsafe assist. Here we have the two Kershaw bumps taken open, and the complaint in the earlier video was that the Kershaw speed bump G10 had a very weak Speedsafe assist opening, whereas the 1595 AL had an extremely strong Speedsafe mechanism. And here's the scales. We have the G10 and we have the aluminum. Okay. It's clear that the Speedsafe mechanism on each is different. Here we notice the G10 model. This is not anchored anywhere. It's just free floating inside the scale. So it's just free floating in here. Whereas the aluminum model, the 1595 AL, here's the inside of the scale, and we can see that the torsion bar here goes through the steel liner and it's anchored into the backspacer. So it's actually both anchored into the steel here and also anchored into the backspacer. And you can see here too from the different cutouts in the scale. The one here has a smaller cutout where the torsion bar just kind of floats free. Because that end there is just flat. There's nothing to it there. It just goes there and it stops. Whereas this one, it goes through the steel liner and it anchors. And that's the aluminum scale. We can see the cutouts different. It has a larger cutout. It comes more towards the back spine to allow for this here to go through into that backspacer. And my guess here, I also did take open I've taken open both of these Kershaws here. Both have very good, strong Speedsafe assists. The Kershaw Clash has a similar model to this, a similar style where it's anchored into the backspacer. And the Blur is open construction. So I was wondering, how is the Blur doing it? When I took this open, if you notice, this has the aluminum scales that are pretty thick. It's actually anchored inside of the scale. So where you see these cutouts here in the scale, it's as if right there it would have another cutout, another indentation that would anchor in, and it would ride up and down. Instead of coming through the other direction toward the blade, it anchors into the scale, closer to the outside of the scale. So it anchors in there. And both of these here and the aluminum speed bump all have something to anchor against. The end of that torsion bar is something to anchor against. See this, it can only go there to there. And once it's at one end, it has that to anchor against for the mechanism to perform. Whereas this one here, get a wider view there, it doesn't have anything, so it's kind of just pushing off the inside of the scale with just that end, almost like the wire end, the rod end of the torsion bar. So that's probably the explanation for the difference in the strength of deployment of these Speedsafe mechanisms. All the ones that have something to anchor against give a very strong deployment, whereas this 1595 G10 with nothing to anchor against, just the free floating here torsion bar. See, there's nothing on the end for that to anchor on. That gives a very weak opening. Here we see this. It's got that end there. Give us a view of it. So this torsion bar goes on and it anchors into the steel liner and into the back spacer. This one here, nothing to anchor against. Just that end of the torsion bar pushing against the opening of the recessed portion of the scale, the G10 scale. So just kind of like the end of it there, pushing against the edge of the scale, versus this, which has that entire part there anchored in. And this is really a difference in design, because at first I was thinking, hopefully by taking these open, it would be possible to get the 1595 G10 to perform like the aluminum model, to do something in here. But looking at this, it appears that if you were going to do the mod, you'd actually have to do quite a few things here. You would have to first go through the liner here, the steel liner, and make that opening, and you'd have to make it just perfectly right. And these two are pretty much on the outside the same shape, so you could line them up and kind of stencil that in. So that would be first. Next, you would have to mill out the inside of the G10 scale. And again, here you could kind of match that opening here. And I don't know if that part here is going to be a problem if it goes lower or whatnot, but you'd have to actually mill that so it'd be just right to line up this portion here for the torsion bar to anchor into the back spacer. So that would be real important to get that to line up there. So overall, it doesn't look like a mod that's very feasible. And one thing here, while I have these open, I'm just gonna take a quick look inside the aluminum model here. I'm just gonna set this down for a moment. I'm just gonna take off that inside part of the steel liner of the aluminum one, just to see if there's anything else on the inside there that's different between the G10 and the aluminum model here. Okay, that's the inside of the scale there. So take this and set it down for a moment. And looks like the other side of the steel liner between the two, between the aluminum speed bump and the G10 speed bump, is the same. I did see on a forum, and I mentioned it in the other video that people on forums were believing that the aluminum model was actually a double pumper, a double torsion bar assist, similar to the Kershaw offset, but looking here, it is not. It looks like there are some extra holes in the bottom of the blade, which may have led people to believe that that was in fact the case, where it is not. There is only one torsion bar in here. So that's a conclusion on the inside difference of the model 1595 G10 Kershaw speed bump.